Balancing acid redox, take 3. Okay, so hopefully you've read, not hopefully, you have read in the book about oxidation reduction reactions taking place in acidic and basic solution. What we have not talked about previously necessarily, we did know that acids usually start with H for this class and bases usually end with OH, because we did talk about acid-base neutralization earlier. But basically, an acid is anything that gives off H plus ions when you put it in water. So you've got, if we're doing it in acidic redox, we've got H pluses available, we got OH, and we got water available at all times, however much we need. Don't worry about it. Okay. So, and then base, we've got OH minus wherever we need it for the same reason. So let's work on these 4. They're on page 5 on the big beautiful packet. So what we need to do first, I don't know how it said it in the reading, but here's what I'm going to tell you. We need to take our equation, easy for me to say, split it in half. So we need to have an iron half. And we need to have a manganese half. And remember, unless otherwise mentioned, these are all in aqueous solution. That means they're dissolved in water. So we, according to the rules on the board, we balance anything that's not H or O like normal. And the charges are not involved in that. So we got 1 iron on both sides of the arrow on the first one, so it's balanced. We got 1 manganese on both sides on the bottom one, so it's balanced as far as manganese goes. Next, we balance oxygens by adding H2O. So I've got 4 oxygens. I'm going to need 4 H2Os. I've got no oxygens in the iron half, so it doesn't need to do that. Then next one on step 3 says balance H's by adding H pluses. I've got 8 H's here in the 4 H2Os, right? 4 times H2O would be 4 times 2 H's. All right, so I got 8 H pluses over here to balance that out. Next, we need to balance charges by adding electrons, and we're going to add the electrons to the more positive side. So I got +2 and I got +3. I'm going to add electrons to the +3 side because it's more positive than +2. It's more positive by 1 electron. On the bottom, I've got +8 and -1. That is +7 on this side. On this side, I've got +2 and 0. So this side is +2. How do we get from 7 to 2? How many electrons will we need to go from 7 to 2? Correct, 5. And we're going to add them to the side that's more positive. +7 is more positive than +2. So I'm going to add 5 electrons to this side. All right, now I'm going to clean some stuff up here. Alrighty then. Next, I need to make sure that my electrons are the same on both sides. Right now I've got 1 electron on the iron half reaction and 5 electrons on the manganese half reaction. They need to both be the same. I can multiply the top one by 5, and then I get everything electrons-wise the same. So I'm going to add those 2 equations together. I'm going to keep the electrons on the outside. Okay, so everything that was on the left side of the arrow is still on the left side of the arrow. Everything that was on the right side of the arrow is still on the right side of the arrow. In addition, I like to make sure that, and this is just a me thing, this is not a requirement at all, the order that they're in originally, I like to keep them in that same order. So the Fe, Fe, MnO4, MnO4. Fe, Fe. Mn2 plus, Mn2 plus. Then anything that we've added extra goes on the outsides. So the H plus and the H2O, those are outside of what was originally. See what I'm saying here? This part is the same here. Not a rule, just my way of doing it. Okay, so now then, anything that's the same on both sides can cancel. Okay, let me say that again. Anything that's the same on both sides can cancel. So I'm going to cancel the 5 electrons. So my final answer is this right here. Sorry, a little sloppy. That's number 1. Number 2, I'm going to have a 10 half. I'm going to have an iodine half. Remember, we're in acidic solution. We can add H's and O's as necessary by adding water and hydrogen ions. So first thing, remember, is are the 10s the same number of atoms of 10 on both sides? Yes. Are the number of atoms of iodine the same on both sides? Yes. Next, waters by adding O's by adding water. So I'm going to add 3 H2O's here. I don't need any on the top because there's no O's in the top half reaction. H's by adding H plus. I've got 6 H's in the H2O's, so I'm going to add 6 H plus. And then charges with electrons. I've got +2 and +4, so I need to add 2 electrons. Always add the electrons to the more positive side. I've got +6, I got -1, I got -1, I got 0. This is +5. This is -1. The difference between +5 and -1 is 6. So I need to add 6 electrons, and I'm going to add them to the more positive side. +5 is more positive than -1. 6 electrons. Cleaning up. Oops. I just leave that other one there. Okay, so we're going to add these together now. 6 H pluses. SN2 plus. Oh, wait, we're not ready for that. We're not ready for that. What am I doing? The electrons have to match. Oh, undo that. The electrons must match, and they do not. So I need to multiply the top one by, you guessed it, 3. Now we've got 6 electrons on each side. I'm going to go ahead and cancel them right there. What do you say about that? 6H plus, 3SN2 plus, IO3 minus, 3SN4 plus, I minus, 3 H2Os. You could count everything up, like there are 6 H's on the left, and I see 3 H2Os, which would be 6 H's on the right. I got 3 SNs on the left, I got 3 SNs on the right. I've got 1 I on the left, I got 1 I on the right. I've got 3 oxygens on the left, I got 3 oxygens on the right. Everything is balanced. The charges should also balance. +6, +6, -1 would be -11. Or I'm sorry, +11. On this side, we got +12 -1 would be +11. So it seems like the charges are balanced also. So that problem is done. Here is your final answer. All right, let's do number 3 real quick. S -2, S, NO3 minus, NO. Okay, the S's look good, the N's look good. I got 3 O's and 1 O, so I need 2 more O's, right? Because we need 3 on both sides. I only had 1. I got 3, I got 1. Now I've got 2 more. So that's 3. I'm going to balance H's next with H+. I got 4 H's there. See them? And then balance charges with electrons right there. That S is a 0. So -2 to 0. I need to add 2 electrons to the more positive side. 0 is more positive than -2. Add 2 electrons. This is +4. This is -1 for a total of +3. This side is 0. I need 3 electrons on this side. Next, I got to make my electrons cancel. And the only way they can cancel is if they're the same. The only way they're the same is if they multiply by some number. I got a 3 here. I got a 2 there. I'm looking for a 6. So I'll multiply my top one by 3. My bottom by 2. Now my 6 electrons are going to cancel. Oops. And we'll add things together now. 8H plus, 3S minus 2, 2NO3 minus, 3S, 2NO, 4H2O. Everything should cancel, or everything should be the same on both sides. I'm looking at the charges. I got +8 and -6 and -2, so that, +8, -6, -2, that adds up to 0. This is already 0. We are good to go. Get rid of all this. There's my final answer. All right, we got one more, and it's basic redox. And let's do this. Let's say we'll start out like it's acid. And then we'll deal with that. So that's the first thing, and there'll be another point down here. So we got to do the Mn side. And the H side, or H and O side. All right, so the MNs look good on the first one. All that's left is H and O's. So we're going to balance the O's by adding water. So I'm going to add 2 waters, right? We got 2 O's there. I'm going to balance the H's with H pluses, so I need 4 H pluses over here. On the bottom, I got H2O2, so I need to add another water. I could do plus H2O, or I could just say 2 H2Os. So now I've got 4 H's on the left, but only 2 on the right, so I need 2 H pluses here. And then I'm going to need 2 electrons to balance that out. I've got a +2. And +4, so I need 2 electrons over here. Well, that worked out nice. Electrons just cancel. 2H plus 2H2O. 2H2O, sorry. Wait a minute. Plus Mn2 plus H2O2 makes MnO2 plus 2H2O plus 4H plus. I'm thinking that my H2Os are canceling because I got 2 of each of those. I've also got 2 H's here. I got 4 H's there, so I can cancel 2 of those. See what I'm saying? So now I'm left with Mn2 plus H2O2 yields MnO2 plus 2H plus. Now, we said we'll start like it's acid. So far, we've done it as if it were acid. Now, what we got to do to make it basic, add OH minuses to both sides to cancel H pluses. I've got 2 H pluses. I need to add 2 OH minuses. Have to add them to both sides. Now this H plus and OH minus will turn into be H2Os. So final answer, 2OH minus, Mn2 plus, H2O2, MnO2, 2H2O. That's a fun problem. Fun problem. All right, perhaps there will be another sheet for you to do a few of these depending on the time, and I will let that be the end of this video. So hopefully I will see you Friday.